So in our last video of the chapter 14a, we're going to look at the step 4.3, testing the quality of the population model. So we're going to learn two different methods you can use to testing the quality of the sample population model. So first is called the significant hypothesis testing. Another one is called the confidence interval of slope. And so why we need this step? Because after the second step, 4.2, we will be able to know if the linear regression model can be able to capture the sample data. So before we can use the model itself to predict the population, we have to prove our sample model can be used to representing the population. So the method we're going to use is called hypothesis testing and a confidence interval slope. So let's start. So testing the quality of the population model, significant hypothesis testing, or confidence interval of slope. So first of all, what is testing for significance? So to test for the significant regression relationship, we must conduct a hypothesis test to determine whether the value of the beta 1 is 0. So before we keep moving on, I want you to think about, so why, first of all, did you notice that we are not testing B0, B1, we are actually testing beta. So which means we are not testing the sample data's value, parameters value. Instead, we are testing the population's parameter, beta. Why? The reason is we already estimate the value of B0, B1. It is obviously it's not 0. You don't need to prove it's not equal to 0. It's the fact it's not 0. So the reason we need to test for the population is because we don't know the population. We only know the sample data. We want to see, based on the sample data, can we prove beta 1 is not 0? So the first thing, pay attention, when we do the hypothesis testing, we are testing beta, its population. So when you work on your homework, you should be able to show me you understand the difference. So if you have the problem to find the beta on your Word document, you can use capital B. Please don't use smaller b, because you just make me to think you don't understand you are testing the population model. So we're testing the beta 1. So some student might ask, why not beta 0? Why we are testing beta 1 equal to 0 or not? Why not beta 1 equal to 5? So why has to be 0? Why has to be beta 1? So let me explain that a little bit. So think about the regression model we learned so far, the simple linear regression model. So let me look at the population model. Expected value of y equal to beta 0 plus beta 1 x. So this is what we learned called a simple linear regression equation, and y equal to beta 0 plus beta 1 x plus arrow term. So this is called a simple linear regression model. So that's what we learned at the very beginning of this chapter. So think about, if beta 1 equal to 0. So think about, if beta 1 equal to 0. My question is, if x change, will that affect y? 2 seconds. 1, 2. The answer is no. If beta 1 equal to 0, x won't affect the y, right? Because if beta 1 equal to 0, y basically will equal to beta 0 plus arrow term. So no matter how x change, y won't change. So in another way, if beta 1 we prove is 0, that means x won't affect y, right? So that's basically what we try to test. We are not testing beta 0 because beta 0, it won't indicate a relationship between x and y. So the beta 1 is the one to indicate how x and y are related. And so the reason we're testing 0 is because if beta 1 equals to 0, that actually indicating x and y has no relationship. So that's why when we are doing the hypothesis testing here, we are testing beta 1. So keep in mind two very important information. First, we are testing beta. We are testing beta 1, not B1. Second, we are testing whether beta 1 equal to 0 or not. So to do the hypothesis testing, we have two different tests, F-test and the t-test. I will show you both But I want you to keep in mind, in chapter 14, when we are learning the simple linear regression model, both F and the t-test, they are the same test. So they are the same test. F and the t-test, they are the same test. So don't get confused. So that's why when I show you the two different tests, you will see the result will be exactly the same. The result will be exactly the same. So let's look at the F test first. So when you work on your homework and work on the practice question, I will require the 4 steps. So what are the 4 steps? So here they go. So the F test 4 step will be step number 1, write down your hypothesis. Step number 2, finding the p-value. If you read the book, they also ask you to find F statistics. So in this class, I only require p-value. The main reason is because if you are relying on the F statistics, you won't be able to have access to the F table, and you actually won't be able to perform your significant test. And also, if you're using the p-value, later I will show you, no matter what kind of test you're working on, you always follow the same rule to decide whether you're going to reject your hypothesis or not. So step number 3, what is the rejection rule to guide you to reject HO? And step number 4, what is your decision, whether you reject or not reject HO? And the second, what is the conclusion? So the conclusion is related to if you can find a significant relationship between X and Y variable. So let's look at step number 1 for F test, how it look like. So step number 1. So the HO is the hypothesis we try to test and I try to prove if we can reject it or not. So the beta 0 is beta 1 equal to 0. So which means we are assume by default, we are assuming x, y has no relationship. So beta 1 equal to 0 means x, y have no significant relationship. So the H alternative, which means if you cannot reject HO, you might you have the alternative that is beta 1 not equal to 0. So don't flip your HO and H alternative. So your HO is beta 1 equal to 0 and H alternative is beta 1 not equal to 0. And the step number 2, finding the p-value on Excel output. I will show you pretty soon using the employee share and how many years they work for the firm as the example to show you where to find p-value. Step number 3, the rejection rule. So no matter you're working on the t-test or f-test, like I said, in this class we only use the p-value. If you're using the p-value, that makes your life really easier. So the rejection rule always the same. You're going to reject HO if the p-value is smaller and equal to alpha. So in this class, by default, the alpha value always equal to 0.05. So put in your mind, so by default, alpha value always equal to 0.05. So which means if you find the p-value in Excel, if it is smaller than 0.05, and then you will reject H null. So you will reject H null. So let's see if you find the p-value is 0.023. So 0.023. You find it on the Excel equal to 0.003. Will you reject H null? Yes, you're going to reject because 0.023 is smaller than 0.05. You're actually going to reject HO. So if you reject HO, which means you're going to reject beta 1 equal to 0. So which means beta 1 won't equal to 0. So what's the relationship between X and Y? Yes, X and Y will have a relationship. But here I want to input a very important keyword. We don't see X and Y as relationship because no matter what, X and Y always should have a relationship. But here we just try to test out the statistical significance. So that's why we're going to see X and Y has a significant relationship. So this is our F tests. So next, we look at the same example we used before. And so if you cannot remember this example, make sure and you go to previous slides to look at it. So we look at 8 employees to look at how many shares they own and how many years they work for the firm. And so in order to find the p-value for the F test, so the p-value for the F test, you need to find that the second table called the ANOVA. So if you don't remember what is that, I go back a few slides. Do you remember this is the handout I asked you to print out, chapter 14 handout? So the second table ANOVA. So the second table ANOVA. So you're gonna notice that at the end, the second column from the last called F. So the F is the F statistic. We won't use it. So the p-value we're going to use to do the hypothesis testing is under the column called the significance F. So the significant F in this case is 0.0077. So this is the p-value. So now if you think about our 4 steps. So now we got the p-value is 0.0077. Will you reject H non? Of course, it is smaller than 0.05. You're actually going to reject. So then your conclusion will be the year and the year and the share will have a significant relationship. Let me show you the answer for this question. So first of all, step number 1, we write down the hypothesis. You can use the word or you can directly use in the symbol you see in the previous slides. Beta 1 equal to 0, beta 1 not equal to 0, p-value 0.0077, rejection rule, p-value is more than 0.05, you reject HO. And so the decision is reject since 0.0077 is more than 0.05. And then your conclusion is related to this case. So the year and the share has a significant relationship. Therefore, the year will significantly affect the share. So the keyword in the conclusion will be this, significant. So when you work on your homework or when you're taking the test, if you don't have this keyword, you're actually going to lose points. As I said, no matter what, any two variable always have a relationship. Here we are testing if this relationship is significant. So this is the keyword. So this is the F test. And so how about the t-test? Like I said, F and the t-test will be the same test when we look at a simple linear regression model. So you're actually going to notice that this 4 step will look very similar. So first look at this t-test. They also go through 4 steps. Step number 1, hypothesis. Exactly the same hypothesis as the F test. And the p-value, where to find p-value will be different from the F test. I will show you where it is later. So the rejection rule is still the same. Reject HO if the p-value is more than 0.05. And then you're going to make a decision, write down the conclusion. So now I will show you where to find the p-value. So let's go back to that handout you have in your hand. So look at these 3 tables. Where is the p-value? So I want you to look at the 3rd table on this Excel output. And the last time we know where to find the B0, where to find the B1. And now we're going to find the p-value to test out our slope, the beta 1. So now look at the same table. There is one column called the p-value. So under this column, you see 2 values. So which one is the p-value for beta 1? So keep in mind, all the information in the first row is related to B0. So which means all the information in the second row is related to the slope, B1. So that's why in order to do the hypothesis testing, t-test, you should use the value in the second row in the p-value column. So this is a 0.0077. Does this number look familiar to you? Of course, because that's exactly the same number you saw for the F test. So now go back to think about what I said. F and the t-test, they're actually the same test when we look at a simple linear regression model. So after we obtain this useful information, let's put everything together and then write down our 4 steps for the t-test. So again, exactly the same 4 steps because F and t-test, they're the same test. Beta 1 equal to 0, beta 1 not equal to 0. First step. Second step, p-value 0.0077. Step number 3, the same rejection rule. Reject p-value or reject H non if p-value is more than 0.05. Since the 0.0077 is more than 0.05, that's why we actually going to reject H non. So therefore, the year and the share have a significant, the keyword significant relationship. Therefore, the year will significantly affect the share. So this is the hypothesis testing.